Hi, I'm Shannon Kliski. I'm the lead product manager for analytics and data science. And in the latest release of ArcGIS, we're continuing to integrate new deep learning models and frameworks so that we're making it easier for you to get started. Let's see how it works. We now include 15 deep learning models in the ArcGIS API for Python. So all you have to do is pick a model that fits your problem and start training. We'll start here in Jamaica Bay, New York. Now what we want to do is create a deep learning model that will detect the boats that are in the bay. We want just those in the water and not those that are sitting on land. Let's dive into our model. Now, I'm going to go through this quickly, but don't worry. Throughout the conference, there will be sessions streaming and on demand that will walk you step by step through everything I'm going to show. Okay, first up, we want to bring in some ground truth data. Basically, we want to teach the model what it is that we're looking for. Next, we're ready to start the training process. We're going to call one of those 15 models that we saw earlier, this one called Mask RCNN. Then we're going to point it at that data we brought in. Next, we'll use the built-in learning rate finder to identify an optimal learning rate, let the model train, and then validate our results. And once we're satisfied, we just save our model, and that's it. So let's take a look at the results. We can see that the model did a really good job identifying boats in the water. Now when we get updated imagery in the area, all we need to do is rerun our model and we'll get an updated feature class of boats in the bay. But what happens when what we want to analyze sits beneath the surface? In 2012, Superstorm Sandy hit this area pretty hard, and we can see that hundreds of ships sank in this bathymetric survey that was collected shortly after the storm. But using that same deep learning process that we walked through, even the same Mask RCNN model, we can create a new workflow that will help us identify the sunken boats in this bathymetric data. Here are the results. But we can also take it a step further. We can use the features generated from our deep learning model to update the nautical charts in the area, making quick work of an ordinarily manual task. But we aren't limited to finding features in images and rasters. We can also use deep learning to help build beautiful 3D scenes like this. Here's how we did it. We start with a raw point cloud, and after a little bit of training, we created a model that was able to correctly classify the LiDAR data, identifying buildings, trees, and ground features. And this is where a lot of AI would stop. But by isolating the trees, we can go a little bit further. Using the spatial analysis tools in ArcGIS, we can create individual clusters in that tree point cloud, taking the highest point from any individual tree to approximate tree height, and using geometry tools to calculate an approximate tree canopy circumference. Then all we need to do is switch out our point cloud for some 3D symbols, bring back in our textured buildings, and we have a beautiful 3D scene with the help of deep learning. And these same deep learning capabilities will be available in the 3D base map solution for local government later this year, making them more accessible than ever. And that was just a quick tour of some of the ways we've incorporated deep learning into ArcGIS. And we're excited to see what you do with it.